Now that we're at the last chapter of the course, it's useful to take another look back at the waste hierarchy and just situate ourselves. So with thermal treatment, we're really focused on the bottom of the triangle here. The main focus is definitely disposal, with the key advantages of thermal treatment being one is the volume of the waste is going to be much smaller after it's thermally treated, and it's also going to be less degradable. It's going to be more inert, and there's less going to happen with that waste once it's put in a final disposal site. There are also significant energy recovery opportunities and some materials recovery opportunities. So with incineration, this comes down to using the ash for things or pulling metals out of the ash. And with gasification and pyrolysis, there's opportunities to take some of the gas, solids, and liquids generated and actually use those to make new material. So that's more in the recycling kind of phase. So both thermal treatment and landfills are kind of overlapped in places at the bottom of the hierarchy here. And in different scenarios, either landfilling or thermally treating and then landfilling may be appropriate for the goals a solid waste system is trying to achieve. Thermal treatment has been one of our oldest forms of waste management, along with open dumping, and it's still widely practiced, especially in places where they just have no other options for waste management. You can imagine if you're living somewhere where the waste kind of just piling up in the streets, there's really nowhere for it to go. By thermally treating it, you're able to reduce the volume down to just the ash that's left over, and that's going to reduce the ability to generate leachate and odors and attract pests and all these other hazards of having the solid waste in its original form. So that's why it's an attractive option and widely used, but it's releases a lot of air pollution, as you can see in the picture. And that's really just the particulates you're able to see, but there's lots of other air pollutants that you can't see. And we'll talk about how those arise from thermal treatment and how they're dealt with at the end of this chapter. So this form of thermal treatment is still widely practiced where there isn't access to other waste management technologies, and similar practices to this were used even in the very rich countries in the world until relatively recently. Now, along with the obvious waste disposal and energy advantages of thermal treatment, even traditional forms of thermal treatment had some energy recovery, or sorry, materials recovery involved, with both the ash and the char having many uses traditionally for things like fuels and metallurgy and agriculture. And Veritasium has a great video specifically on how potash can be produced from ashes. And this is something we touched on when we were looking at organic waste treatment, how specifically potassium and phosphorus could be recovered from organic waste to stop us from mining it. And you can also recover some of these minerals from ash from thermal treatment as well. So you can check that video out. In New York City, they had thousands of waste incinerators in the mid 20th century, and you can see from the picture what their local air quality was like. You know, due to those incinerators and other things going on, automobiles and coal and things like that. But if you read the description, it's pretty shocking the state that things were in at that time. There's talk of children, you know, catching the ashes falling from the sky like snowflakes, and the ash just piling up in the sediments in Central Park and things like that. So it's pretty shocking the extent that thermal treatment was affecting that local environment at that time. Now we know in New York, as we looked at in our collection, transfer, transport unit, a lot of that waste management has moved out of the city. They don't have any landfills or incinerators in the city anymore. But there's kind of an interesting kind of flip-flop here, because incinerators, unlike landfills, you actually can site safely in or close to cities now, unlike landfills, which need a lot of space and space around them. In Ontario, our two incinerators are both in populated areas in Durham region and Peel region. And that allows them to be located close to the source of the waste and cut down on some of that cost and emissions associated with shipping it out. So because our pollution control has come so far, we're able to do things like that and get some of those benefits, whereas in the past, the local environmental effects were quite severe. And this isn't just happening in big cities, or wasn't just happening in big cities at large scales. It was also something that people commonly did. You'd burn your garbage in your backyard instead of sending it on a truck to be deposited somewhere, because it was just easier and cheaper. So on the left, you can see there's a fellow with all sorts of boxes and pallets and stuff with his backyard incinerator, and you can see how horrible the air quality resulting from that is, with that horrible black smoke coming out of the top. So that was one of the reasons why, at least in California, this practice was banned in the mid 20th century. And at the time, it was seen by the people as like a gross overreach of the government, you know, controlling people's lives in the names of environment. And the picture on the right is people holding a mock funeral for their backyard incinerators. And it's interesting because we are still talking about the same things today, whether government should be involved in air pollution control through things like climate change. You know, just this last week, the Canadian Supreme Court decided that the federal government carbon pricing was constitutional, and provinces without carbon pricing programs would still have to use it. So we're still having these arguments today. Today, thermal treatment doesn't look like those smoky pictures I just showed you. In the picture here, this is a plant in Amsterdam. There is smoke coming out of the stacks, but that's mostly water vapor. About half that plant is devoted to cleaning up the emissions before they go out to the environment. So the hazard still definitely exists, but there's a lot more technology invested and regulations that require those emissions to be cleaned up before they go out into the atmosphere. Most of the plants operating today are incinerators. That's what this plant in the picture is. Pyrolysis and gasification are still a little bit experimental and haven't been scaled up to the same extent. Any of these could be termed, along with thermal treatment, energy recovery, energy from waste, or waste to energy. There's not consistent terminology. Sometimes some of these terms refer to anaerobic digestion as well, which has energy recovery aspects. So just be careful if you see any of these terms. I chose to use thermal treatment for this unit because it really focuses on these technologies that use high temperature to react and stabilize the waste, but you might see some of these other terms as well. We've reviewed what these three technologies mean in terms of the actual reaction with my candle in the first video, but here's just another recap. So again, pyrolysis, no oxygen, we're just converting the material into solids, liquids, and gases. Gasification, we're adding a little bit of oxygen to move everything into that gas phase. So we have a mixture of flammable gases. And then incineration, we're adding excess oxygen to burn all that material out and gain the full energy content of it and leave nothing behind but ash. There's a summary of those three different technologies for you, and we will go into each in detail through this chapter. And just for a look at where these technologies are assessed in terms of risk, this slide is almost a decade old now, but it's kind of the same situation. At the top of the chart, you can see that the traditional incineration-based technologies are classified around kind of a low risk. There's a lot of them, especially in Europe. There are more in the US than there are in Canada, but there are a couple in Canada. As a comparison, anaerobic digestion and mixed waste composting, so that would be an MBT type, are classified as a little bit higher risk than that. And that's come down a little bit in recent years, but we're kind of around the same place. They're technologies that people see others doing. There's some investment involved, so not everyone's going after them, but they're all kind of feasible options there. And then at the bottom of the table is pyrolysis, gasification, and then chemical decomposition, which is really just another kind of pyrolysis or gasification. All these are classed as high, and as I mentioned, these advanced thermal treatment technologies aren't really uptaken to the extent that incineration is yet, but maybe we'll see some of that, especially with things like Asian import bans on dirty recycling and EPR growing the size of materials that we'll be gathering. Not everything can be recycled traditionally, and there's ways that pyrolysis and gasification can help us recover those actual molecules and reuse them for something better.